Hello student, how are you? In last video lecture, we saw the numericals that is based on rate law and order of reaction. Okay. Now in this lecture, we are going to start the numerical which is based on integrated rate law for first order chemical reaction. Integrated rate law for first order chemical reaction. Here it is the numerical number first. The concentration of N2O5 in liquid bromine. N2O5 in liquid bromine varied with time as follows. So in chart number first, time in seconds, 0 second, 200 second, 400 second, 600 second. So chart number 2 consists concentration of N2O5 in terms of molarity, 0.15 molar, 0.098 molar, 0.064 molar, 0.042 molar. Show the reaction is first order. So we have to use the formula of integrated rate law for first order chemical reaction. We have to calculate in a definite time interval for rate constant K. So our formula for integrated rate law for first order reaction is equal to K is equal to 2.303 divided by T log to the base 10 A0 divided by AT. Okay, T means time, K means rate constant, A0 means initial concentration of reactant, AT means final concentration of reactant. So we have to find definite time interval. So no doubt that initial concentration at time 0, A0 at time 0 is equal to, here it is 0 second, that is 0.15 molar. Okay, that is the initial concentration. Now we have to solve the numericals stepwise. That is, initial concentration is fixed value. As point to be remember that as time increases, concentration of reactant is decreases. First of all, we have to solve point number first, that is A0 initial concentration 0.15 minute at time T 200 second, that is AT is equal to 0.098. Okay, then initial value is fixed, then time interval is 0 to 400. In first case, please remind that time interval is 0 to 200. Then second case, time interval is 0 to 400. Then third, 0 to 600. Okay. So if the answer is same, then reaction definitely first order. Okay. Now let us find that. In first case, initial concentration A0 at time 0 is equal to 0.15 minute. So AT final concentration at time 200 second is equal to 0.098 molar. 0.098 molar. Okay, that is the step first. Now let us solve that. So this is our given data. Original formula as we know, K is equal to 2.303 by T log to the base 10 A0 by AT. So is equal to K is equal to 2.303 divided by T. T indicates 200 second. 200 second because we have to solve stepwise between two limits 0 to 200, then two limits 0 to 400, then third one 0 to 600. Okay, so 2.303 divided by 200 log to the base 10. Initial concentration A0 is having fixed value 0 second, 0.15 molar. So 0.15 molar divided by AT. AT means first we have to solve in between limit 0 to 200. 0.098 molar. So if we solve this, we get answer that is k is equal to 2.303 divided by 200 log to the base 10. Now we have to divide 0.15 divided by 0.098. Okay, that is equal to 15 upon 9.8 or 150 upon 98. 150 upon 98. If you solve this, you will get answer that is 1.531. I am directly writing here because the basic maths तुम्हाला ते एवढं येत आहे, म्हणजे लॉगचं कॅल्क्युलेशन तुम्हाला येत आहे. 150 भागिले 98 केलं तर 1.53 1.531 हे फक्त आन्सर येणार आहे कशाचं, भागाकाराचं. ओके, देन वी हॅव टू टेक अ लॉग ऑफ 1.531 is equal to, I am writing here, k is equal to 2.303 divided by 200 log to the base, no sorry, 1.531 चा लॉग बघायचा आहे, that is equal to 0.1850. 0.1850 लॉग आपल्याला बघायला येतो, मी डायरेक्टली लिहिलेला आहे. ओके, then we have to solve this example, we get answer. If we solve this example, we get answer that is 2.13 into 10 to the power minus 3. K is equal to 2.13 into 10 to the power minus 3. Okay, that is a second inverse because unit of k, it is reciprocal of time and time is given in second. So second inverse is the unit. So in this numerical number first we can solve easily and we get the correct answer that is 2.13 into 10 to the power minus 3 second inverse. Okay, this is our step number first. I am telling you once again that if I am taking the limit that is 0 to 200, then time must be 200. So initial concentration 0.15, the final concentration within this limit that is 0.098. So 150 divided by 98 is equal to 1.531. If you using log table, you can easily get this answer. Then log to the base 10. Log to the base 10 1.53, it gives 0.1850. Okay, now 0.1850 into 2.303 divided by 200. I am directly writing the answer, correct answer for this numerical because मल्टिप्लिकेशन तुम्हाला येईल, भागाकार येणार आहे, पण त्यामध्ये फारशी अडचण नाहीये. 2.13 into 10 to the power minus 3 per second हे माझा आन्सर आलेला आहे. ओके, प्लीज रिमाइंड दॅट. नाउ इफ वी टेक second step, that is k is equal to, this is original formula. Now initial concentration that is A0 will not be changed. 0.15 molar at time is equal to 0. Then final concentration AT is equal to, now limit is changed, now limit is 0 to 400. Final concentration is 0.064. Okay, so this is our at time 400 second. This is our basic given data. We have to solve this example. So we get k is equal to 2.303 divided by time. Now time is 400 log to the base 10 divide A0 that is 0.15 molar divided by what is the value of 400 concentration 0.064 molar. Now we get correct answer for the dividation 2.344. 2.303 divided by 400. Firstly तुम्हाला याचा भागाकार करायचा आहे, log to the base 10 2.344 एवढं आन्सर येणार डिवायडेशनचं. 150, 1, 2. 1, 2. So 150 divided by 64, that is equal to 2.344. Then log of 2.344 is equal to 2.303 divided by 400 into याचा लॉग आलेला आहे 0.3699. 0.3699. Okay. If we solve this, multiply and divide this, we will definitely get same answer. That is k is equal to 2.13 into 10 to the power minus 3 second inverse. We will get definitely this answer. Okay. So don't worry about that. तुम्ही फक्त एका स्टेपचं कॅल्क्युलेशन केलं की पुढच्या सगळ्या लिमिटचं आन्सर जे असते ते सेमच येते. फक्त एका स्टेपचं कॅल्क्युलेशन सेम करायचं. 0 ते 200 सेकंद लिमिट मध्ये एवढं जे आन्सर येईल तेच 0 ते 400 सेकंद मध्ये येणार. तेच आन्सर 0 ते 600 सेकंद मध्ये येणार आहे. ओके. सो दिस इज अवर सेकंड स्टेप. इफ वी solve the third step, that is initial concentration A0 is equal to 0.15 molar. Initial concentration at time 0 will not be changed. Then between two limits 0 to 600 seconds, that is concentration. Final concentration, it is equal to 600 at time 600 seconds is 0.042 molar. If you solve this, so you will definitely get this answer. K is equal to 2.13 into 10 to the power minus 3 second inverse. So सांगायचंय काय आपल्याला या एक्झाम्पल मध्ये, कुठल्याही लिमिटचं एका स्टेपचं कॅल्क्युलेशन केलं तर पुढच्या कुठल्या स्टेपचं कॅल्क्युलेशन फारसं सिरियसली करायची गरज नाही, कारण की आन्सर तेच येतं. तुम्ही 0 ते 400 मध्ये केलं तरी आन्सर हेच येणार. 0 ते 700 मध्ये ट्राय करा, आन्सर हेच येणार. ओके. बिकॉज कॉन्सन्ट्रेशन डेफिनेट टाइम इंटरवल मध्ये डिक्रीज झालेलं आहे. कुठल्याही एका लिमिटचं घेतलं त्याचं जे उत्तर येईल रेट कॉन्स्टंटचं तेच पुढच्या रेट कॉन्स्टंटचं उत्तर येणार. सो व्हॅल्यू ऑफ के इज रिमेन सेम. सो रिएक्शन इज फर्स्ट ऑर्डर. ओके. दिस इज अवर फर्स्ट एक्झाम्पल. अवर सेकंड न्यूमेरिकल इज द न्यूमेरिकल that is based on half life. The half life of first order reaction is 0.5 minutes at certain temperature. Calculate number first, rate constant, and second, time required for 80% reactant to decompose. Okay. Now first of all we have to calculate rate constant. So I am writing here correct given data. Correct given data. What is the given data? The half-life of first order chemical reaction is 0.5 minutes. So symbolic representation T1 half is equal to 0.5 minute at certain temperature. Temperature is not giving directly to us. So we have to calculate rate constant. What is the symbol of rate constant? K is equal to question mark. Okay. Now what is the formula? I am you have already know what is the formula for half life of chemical reaction. That is equal to T1 half is equal to 0.693 upon K. This is the formula for half life. Now we have to calculate K. So I think the formula should be exchanged. So K is equal to 0.693 divided by T1 half. So it directly gives the value of K, that is the number first, rate constant. Okay. Now we are solving this. So number first, rate constant K is equal to 0.693 divided by T1 half. T1 half. Okay. So I am writing the values, that is 0.693 divided by what is the half life for certain 0.5 minutes. So you have to solve this because मला व्हिडिओ लेक्चर मध्ये लॉग टेबल बघून ते करणं थोडंसं इम्पॉसिबल राहते. त्याला it takes lot of time. So I am directly writing the answer for that. 1.386 per minute. 1.386 per minute. ओके, तुम्हाला कॅल्क्युलेशन बेसिक लॉग अँटी लॉग सगळ्यांना येतो, लॉग अँटी लॉग. ओके, ते यायलाच पाहिजे. सो 0.693 upon T1 is equal to 1.386 per minute. Okay, because half life is given in minutes, so इथं 0.5 मिनिट टाकल्यावरती गेल्यावरती per minute. This is the answer for rate constant K. Okay, now how to solve point number 2, that is time required for 80% reactant to decompose. Okay, now please take screenshot of this. Okay, now we are going to start, that is second point, time required for 80% reactant to decompose. Now I am writing here our rate constant K value. Our answer is 1.386 per minute. Okay, now how to solve time required for 80% reactant to decompose. Now let us find that 80% reactant decompose. So initial concentration must be, initial concentration, we have to use this formula, integrated rate law for first order reaction, 2.303 divided by T log to the base 10 A0 divided by 80. But direct value is not giving us, so we have to solve, we have to find the exact value of A0 and 80. Now please remind that 80% reactant to decompose. What is the time required for 80% reactant to decompose? 80% reactant decompose व्हायला how much time is required? So initial concentration must be 100%, 100 molar. Okay, 80% reactant to decompose. So 80% reactant decompose झालाय, होतोय म्हटल्यावरती 100 minus 80, 100 minus 80. So 80 and 80, I'm just kidding. 80. So it gives 20. Okay, the value of 80 is equal to, not 80, value of 80 is equal to 100 minus 80, it gives 20. So initial value, that is 100. 100तला 80% डिकंपोज व्हायला वेळ किती लागेल? मग इनिशियल 100, 100तला 80 केलं म्हणजे 20. फायनल कॉन्सन्ट्रेशन किती झालं? 20. ओके, सो याचा विषय मिटला. यानंतर काय, how much time? So I think we have to exchange the formula. The T, इथं T आहे म्हटल्यावरती T लेफ्ट बाजूला घेतला. So T is equal to, what is the formula for T? T is equal to 2.303 divided by K log to the base 10 A0 divided by 80. Okay, this is our formula because we have to find time. So I want time to be in left side. So T is equal to 2.303 divided by K log to the base 10 A0 by 80. So putting the value 2.303. What is the value for K? The value for K is 1.386 per minute. 1.386 per minute. Log to the base 10. What is the value of A0? That is equal to 100. Initial concentration, इथं तुम्हाला 50% दिलं तर इनिशियल 100च, पण फायनल 100 वजा 50. इथं 10 दिलं 10%, इनिशियल 100च, फायनल 100 वजा 10 म्हणजे 90. असं 180, it is the final concentration, that is 20. Okay, now we have to solve. What is our next step to calculate for this numerical? That is T is equal to 2.303 divided by 1.386. So log to the base 10, 100 upon 20. Let us say it is 5. First of all 100 upon 20 we get 5. Now here T is equal to 2.303 divided by 1.386. What is the value of log to the base 10? So you have to नो, बाय युझिंग लॉग वी हॅव टू सॉल्व बाय युझिंग लॉग टेबल. आता मी या टाईपचे न्यूमरिकल जे आहेत ते प्रत्येकाचं लॉग बघून हे सॉल्व्ह करू शकत नाही. मग एक न्यूमरिकल एक लेक्चर, 1 तासाचं लेक्चर व्हायचं. तेवढं तुम्हाला बेसिक लॉग, अँटी लॉग कॅल्क्युलेशन येते, ते बेसिक आहे. जेवढं डिफिकल्ट असेल तेवढं मी माझ्या परीने लॉगचे नियम सांगण्याचा प्रयत्न करतो. सो लॉग टू द बेस 10 5 इट गिव्स, आता याचा लॉग 0.699, कॅरेक्टरिस्टिक 0, याचा लॉग मी डायरेक्टली बघितला. बरोबर, माझं काही पाठ नाहीये, पण मला थोडं थोडं जे माहिती ते लिहिले. लॉग टू द बेस 10 5, लॉग टू द बेस 10 5 चा लॉग हा झाला 100/20 is equal to 5. Then log to the base 10 5 is equal to this. Okay, now we have to solve, multiply this 2.303 into 0.699. Okay, so what is our next answer? 2.303 into 0.699, it gives 1.609 divided by 1.386. 1.609 divided by 1.386. Now what is our final answer? So 1.162. T is equal to 1.162 per minute. This is our final answer, 1.162 per minute. Because calculation प्रत्येक स्टेप मला करणं या व्हिडिओ लेक्चर मध्ये ते पॉसिबल होऊ शकत नाही ना. प्रत्येकाचा लॉग बघा, अँटी लॉग, बेरीज वजाबाकी, पुन्हा सॉल्व. ओके, त्यातनं एखाद्याला वाटलं तर त्यांनी सांगावं, मी एक लेक्चर मध्ये त्यासाठी सेपरेट बनवण्याचा प्रयत्न केला. ओके, सो व्हॉट इज द आवर फायनल आन्सर? टी इज इक्वल टू 1.162 पर मिनिट. Please point to be noted that you have to use the formula is based on half life. So you have to use the formula for half life is T1 half is equal to 0.693 divided by K. So what is the value of K? 0.693 divided by half life. So what is the value of K? I think 1.386 per minute. Okay. Now second point is time. But we have to calculate time. The original formula for integrated rate law for first order reaction is K is equal to 2.303 divided by T log to the base 10 A0 upon AT. T इकडे शिफ्ट केला. T is equal to 2.303 divided by K log to the base 10. What is the value of A0? A0 means initial value. 80% डिकम्पोज झाल्या म्हणजे आपण सपोज केले 100% मधलंच असणार ना ते. इनिशियल 100 झालं, फायनल 80, फायनल कॉन्सन्ट्रेशन 100 80 म्हणजे 20 राहते, म्हणजे फायनल कॉन्सन्ट्रेशन 20. ओके, आहे तसं लिहिलं, के ची व्हॅल्यू टाकली, 100 भागिले 20, याचं उत्तर 5. पुन्हा लॉग टू द बेस 10 5, 5 चा लॉग, 5 ची कॅरेक्टरिस्टिक 0, 5 चा लॉग 0.699. त्या दोघांचं मल्टिप्लिकेशन केलं तर एवढं आलं 1.609 divided by 1.386. So what is the calculation? And the final answer is 1.162 per minute. Okay, you have to convert it into second also. So don't worry about that. It is really very easy for us. So this is our second example. Third numerical is in first order reaction A which gives B, 60% of sample decomposes in 45 minutes. What is the half life for reaction? Okay, first we have to write correct given data. Given data. So in first order reaction 60% of reactant or sample is decomposes. So what is the initial value then? A0 is equal to 100. Okay, 60% of sample decomposes. So what is the final value? 80. Want to be rotated that. It is equal to A minus 6 in my second video lecture. 80. So 100 minus 60. 80 is given by 40. Okay, in 45 minutes. So T is equal to 45 minutes. What is the half life of reaction? So half life, the formula of half life T1 half is equal to 0. I think I am here writing a question mark. Okay. So formula of half life is T1 half is equal to 0.693 divided by K. Okay, divided by k. So what is the value of k? It is not directly given to us. So we have to calculate it manually by using integrated rate law for first order reaction. Then putting the value there, we will get correct answer for half-life. This is our basic given data. Initial value that is 100. Final value that is 60% decomposes. So 100 minus 60. Point to be noted that in our first lecture, what is second lecture I think, what is the value of 80 is given by A0 minus 6. A0 means, what is the value of 80? A0 100 minus 10. Okay. So that is also you will get help from that my video lecture number 2. So this is the how to write 80 and A0. 100 मधलं 60% डिकम्पोज झालंय. मिसिंग 100 minus 60 80 is equal to 40. So टाइम दिलेला आहे, टी मला काढायचा आहे. व्हॉट इज द व्हॅल्यू ऑफ के? के दिलेला आहे म्हटल्यावरती के पहिल्यांदा काढायला पाहिजे. सो व्हॉट इज द फॉर्म्युला फॉर के? K is equal to 2.303 divided by T log to the base 10 A0 divided by 80. A0 divided by 80. So I want to write what is the value of K is equal to 2.303 divided by T. T means 40 minutes. 45 minutes. Log to the base 10. What is the value of A0? A0 is 100 divided by, what is the value of 80? 100 minus 60, that is equal to 40. Okay. So now let us find that, or let us solve that. So K is equal to 2.303 divided by 45 log to the base 10. First of all, we have to solve this. 100 upon 40 means 40 गुणा 80, अडीच फूट झालं ना. मग 2.5. ओके. 100 upon 40 is equal to 2.5. Then our next step is K is equal to 2.303 divided by 45. What is the log of 2.5? That is 0.3979. 0.3979. This is the log. Characteristic is 0.3979. Okay. First of all, 100 upon 40, 2.5. 2.5 is the log. Then we have to solve this. Okay. So K is equal to 2.303 into 0.3979 is given by 0.9163. 0.9163 upon 40. 0.9163 upon 40. So 0.9163 upon 40 is equal to, final answer is equal to 0.0204 per minute. 0.0204 per minute. Okay. This is how to calculate first of all rate constant K. Okay, I am telling you once again for this given numerical. So 2.303 divided by T, 45 log to the base 10, A0 100, 80 40. यांचा भागाकार एवढा आला, यांचा लॉग एवढा आला. हे आहे जसं कॉपी पेस्ट केले. यांचं मल्टिप्लिकेशन केलं एवढा आलं 0.9163 डिवाइडेड बाय 40. हे केल्यावरती 0.0204 पर मिनिट हे एवढा आन्सर आपला आलेला आहे. यानंतर वी हॅव टू सॉल्व द प्लीज टेक स्क्रीनशॉट ऑफ दिस गिवन एक्झाम्पल. वी हॅव टू सॉल्व देन another we have to calculate half life for this equation. So what is the formula for half life? T1 half is equal to 0.693 divided by K. Now this is the value for K. So T1 half is equal to 0.693 divided by 0.0204 per minute. Okay, now T1 half is equal to, if we solve this, log of 0.693 minus log of 0.0204, देन फायनल आन्सर आफ्टर मायनस वजा बाकी केल्यानंतर जे उत्तर आहे त्याचा अँटीलॉग बघितला की आन्सर मिळणार तुम्हाला 34 minutes. 34 minutes. This is the half life for this numerical. Okay, it is really very easy numerical. फक्त मॅन्युअली आता मी इथे करू शकत नाही, मॅन्युअली तुम्ही कॅल्क्युलेट करा. लॉग अँटी लॉग बेरीज वजा बाकी हे बेसिक आहे, ते सर्वांना येते. ओके, तरी पण लॉग अँटी लॉग बघण्यामध्ये किंवा बेरीज वजा बाकी किंवा इतर काय डाटा असतील तर मला सांगितलं चालेल. वाटल्यास मी एखादं एक न्यूमरिकल त्याच्यावरती स्पेसिफिक 2 लॉग अँटीलॉग सहित घेऊ शकतो. फक्त त्याला एक पूर्ण लेक्चर 1 तासाचं जाऊ शकेल. पण लॉग अँटीलॉग बेसिक तुम्हाला येतं, त्यामुळं मी फक्त डायरेक्टली आन्सर इथे लिहिले. फक्त ते कसं करायचं त्याचा हे वे काय एवढं मी सांगितलंय. ओके, थँक्यू.